Last time we looked at Life Sciences paper 2 for grade 11, and we continue looking at that paper. The next discussion is going to be on mathematics. We shall discuss on the time. Right, so to start with, we are looking once again at the grade 11, Life Sciences paper 2, there. Right, so the couple of things we looked at last time, and we continue from where we left off. But today we need to start by looking at particularly question 2.3. Right, so we looked at the range of the other questions, but we shall be looking at question 2.3 today. Okay, right, here is question 2.3. Amahle conducted an investigation to determine how different treatments affect the amount of fungi that grows on bread. Right, she took 5 slices of bread and treated each in a different way as follows. Slice 1 was left dry. Slice 2 added 20 ml tap water. Slice 3 added 20 milliliters lemon juice. Slice 4 added 20 milliliters sugar water. Slice 5 added 20 milliliters bleach, which is also called jik. A spray bottle was used to apply the treatment to make sure that it was evenly spread on the bread. Each slice was placed in a Ziploc bag kept in a cupboard for 1 week. Remember, you were just putting these pieces of bread, 5 slices of bread, etc., and leaving one to dry, another one with tap water, and so on. Right after each slice was placed in a Ziploc bag, kept in a cupboard for 1 week. After 1 week, the bread was removed from the Ziploc bags and she observed the growth of the fungi. Right, she calculated the percentage area of the bread covered by fungi. Now, the results are shown in the graph below. Right, so we have the treatment on bread. The dry bread is showing no bar at all on the bar graph. But the bread with the tap water, you can really see that the percentage area covered by fungi, right? The percentage area covered by fungi for the tap water is actually between 20 and 30%, right? The lemon juice there, also, we can see that the percentage area covered by fungi is actually 30%, right? There is sugar water, right, which has shown the biggest percentage of fungi growth. There is bleach that has shown some growth of the fungi, but a little bit less. But the sugar, oh my goodness, you can see that if you put sugar on bread, then the fungi grows a lot. So you're going to see a lot of fungi there. Okay, that's growing on the bread, obviously, as it has been just left that way. And this experiment was conducted by Amahle. All right. Here is the question. Why did Amate put the bags in the cupboard? Okay, so we answered this particular question. Our aim in our discussions is just to make sure that you are familiar with how to answer questions here on certain investigations in life sciences and also examination questions and how to get them answered in general. All right, now let's look at this particular question over here. Right, now, how do we then answer this specific question? Right, so Amate decided to why did Amate put the bags in the cupboard? Why? Because now this, you took the bread and you put them in Ziploc bags. So in other words, you have the bread like that, the Ziploc bags, and inside was the bread. Okay, in the Ziploc bags. And then now this is the Ziploc. What is a Ziploc bag? Okay, obviously you understand that the Ziploc bag are those bags that sometimes are even used in the banks. There's Ziploc, meaning that you see you can put some banknotes in these Ziploc bags, and then you zip them. So where after zipping, then nothing goes out and nothing goes in. Right, but she actually put bread in it. So the first slice was left dry. The second one had water, tap water, lemon juice, sugar water, and then bleach. Right. So, and obviously she put everything there, and then she took this bread and she put in the cupboard. Why the cupboard? For all places, the Amahle. Okay, so we can see that Amahle understands life sciences, and the reason why that is the case is simply because fungi. Is simply because fungi, right, grow best in dark in dark. Right. So Amahle is a word that if you want the fungi to grow very well, you must put your experiment in a dark area. So you must put this in actually a dark, not only a dark and warm, a dark and warm. Yeah, fungi grow best in dark and warm places. Right. So fungi grow best in dark and what and warm places. That's the reason why the cupboard became like the most appropriate place for Amahle to do this life sciences experiment. Okay, next question. Okay, the story is the same there, but we're just answering question about the difference in tap water, lemon juice, sugar water, and bleach. So that is what this is about. Name the independent variable. What is the independent variable? And what do we mean by what we call the independent variable? What is an independent variable? But also, what is it here in this particular investigation? Because this is actually an investigation performed by Amahle. As part of the school curriculum, investigations must be performed. This one must also be performed by the grade 11 learners. Right. So that the independent variable, what is the independent variable? The independent variable is what you are changing, is what you are changing. So what was Amahle changing here? Amahle was changing the treatment on the bread, was changing the treatment on bread. Okay, when Amahle was changing the treatment on bread, she left the first slice was left dry. The second one, tap water, then lemon juice, then sugar water, and then bleach. Okay, what we're observing is that Amahle is just changing the treatment on bread. So what is the independent variable? It is the treatment. So she's just changing the treatment, changing the lemon juice, changing water to lemon juice, and then lemon juice, sugar water, and then she puts or she applies bleach on the bread. But you can see that what is happening after all is that Amahle is just changing the treatment on the bread. Next question. Okay, we have the same story about this is not a scary question. It's just an investigation about taking five slices of bread, from slice number 1 to slice number 5, and then you just put different substances on it. Explain why the dry bread was included in the experiment. Now, nothing grew, no mold, no fungi grew on the dry bread. But why was the dry bread included in the experiment? Because nothing was put on that bread. But why is it here? Why is it on our bar graph when we write our scientific report? Why is it there on the bar graph? We answer that question because we can see that it is what we call, which we have put nothing on it. If we put nothing on it, what do we call that in science? We actually call it the control. So it is, right, so it is the control. Right, it is the control. Right, so it is the control. Because now we have just put nothing on the dry bread. And hence now we can see on the bar graph On the dry bread, nothing grew. But the one with tap water, there was some growth. And then lemon juice, there was a bit more growth. And then sugar, even much more. And then bleach, a little bit less. So we have those observations there. So why did Amahle have to put the dry bread here on the thing, on the bar graph? The reason is because it is the control. Okay, there's something called the control experiment, because we applied no substance at all. We did not really apply no treatment on the dry bread. Since on the dry bread we have put nothing, it is called the control. And we always make observations on what is happening on the control side of things in the science experiments. Okay, so this is extremely important to observe. Okay, so we shall discuss a wide range of investigations that are examinable, okay, because the investigations that come in the exam, we're looking at the second paper, but in our next discussion, we'll also incorporate the first paper, but also we'll also incorporate some theory for learning. And we are interested in applying the theory, not just giving the notes, but we're really saying, how do we approach and how do we answer examination questions? The next one. In 2.3, we are saying state a way or state one way. Right, Amahle can improve the reliability of her investigation. Now we can see that Amahle did this investigation and was able to make observations. But how can Amahle improve the reliability of the investigation? How can she improve the reliability? She just took 5 slices of bread and she was changing the treatments on it. Okay. But how can she make sure that this investigation is reliable? How? Okay, Amahle needs to do the following. To increase the reliability of investigation, you need to repeat and make observations. So you need to repeat the investigation. So after you have done an investigation in science, you need to make sure that you repeat the investigation. Because if you repeat the investigation, you increase the reliability, because now you want to see if the results will be the same or not, and they were not subjected to anything else that influenced the outcomes. Okay. If you do not repeat the investigation, you need to increase the sample size. Right. So you increase the investigation, you rather repeat the investigation, or you increase the sample. You increase the sample size. Right, so you increase the sample size. Right, so in other words, that is what you do to make sure that your results are reliable in science. These are the two things you need to do, because they will ask you this in the exam, that you have an investigation that was done, but how do you make sure that the results are reliable, and how do you make sure that you improve the reliability of your investigation, so that if somebody performs this investigation in another country, in another province, they get the same result. So you need to do this again using new substances. So you need to, if need be, just go to another tap of water, another lemon juice, another sugar water, another bleach, not the same bleach you used, and a different bread. If you took these 5 slices from a given loaf of bread, then you can use a different loaf of bread. Right. So, and you repeat this investigation and you see the outcomes and see if the fungi will grow like this. So that is what is happening here. Okay. Right. Next question. Okay. Amahle is continuing with the investigation in this life sciences exam paper, but now explain why fungi grows best on bread sprinkled with sugar water. Why is it that now sugar water is showing the greatest growth of the fungi? Why? Why is dry bread not growing any fungi? Why is the one with bleach not growing a lot? Why is the one with tap water less? So those kinds of things. Right. Explain why fungi grows best on bread with sugar water. Why? We answer the question. So we look at 2.3.5. Why is that the case? Why is sugar showing so much growth? Here's the reason in science. The reason is that sugar itself provides energy. Okay, if you eat sugar, you become very energetic. So sugar provides energy. Okay, right. So if sugar provides energy, if you want to say sugar, because it contains lots of kilojoules of energy. Okay, so if you drink tea, you are more energetic because now the sugar contains a lot of energy. If you sip on juice, then you have, so you put sugar in your subs in your food, then you get more energy from the sugar. So because sugar provides energy. Right. So, or if you want to say sugar provides energy in these kinds of investigation questions in the exam, you say that food for fungi, right? Or it is food for fungi. Therefore, more food will allow fungi to grow faster, to grow faster. So we're effectively saying here, okay, we're effectively saying here, right, we're effectively saying here, sugar provides energy, right? Or sugar itself is sort of food for fungi, and therefore more food will allow fungi to grow faster. Okay. So, in other words, we agree that the sugar itself is food for fungi, and therefore more food will allow the fungi to grow faster. So in other words, the fungi, also the sugar provides energy. So those are the reasons why we can see the bar there in the bar graph growing the most where we have sugar water added. Okay, next question. Right, give two ways. Give two ways Amahle ensured that the results of this investigation were valid. Give two ways Amahle ensured that the results of this investigation were valid. How did Amahle ensure that the results of this investigation were valid? How? So we observe and we answer that question. Right. So Amahle decided to make sure that the results are valid. Amahle decided to use spray bottle. Spray bottle to apply treatments, right, to apply treatments evenly. So Amahle decided to use a spray bottle to make sure that the treatments are applied evenly. So because if you are just to put the tap water on bread, sometimes you can find that some parts of the bread will have more water than others. Some parts of the bread will remain dry, you know. And to make sure that this water was applied, the treatments were applied evenly, she used a spray bottle. Okay, so that's what to make sure that in particular the results of the investigation were valid. But moreover, there, what happened as well? Right, she decided to place. She decided to place the bread in Ziploc bags. In Ziploc bags. He decided to place the bread in Ziploc bags. So she placed the bread in Ziploc bags. Next, so in other words, she made the point that these Ziploc bags are actually applied for all the 5 slices of bread. Next. Next. But she also ensured that all slices placed in cupboard. That is very, very important. So she decided to put all the slices in the cupboard. Right, she decided to put all the slices in the cupboard, no exception. All the 5 slices were put in the cupboard to make sure that the results were valid, because she did not leave another slice somewhere else, under the table or outside in the sun. She did not do that. She made it a point that she put all the 5 slices of bread in the cupboard. That is the advantage of what Amahle did. Next point about why Amahle made it a point but this scientific investigation itself is actually more valid. Okay, so all left, right, all of the slices of bread were all left. All the slices of bread were all left for 1 week. Right, they were all left for 1 week, or the same amount of time, or just they were left there for the same time. Okay, next question. Now, next point about the reliability of the results of the investigation were valid. The same sizes, the same sizes, slices, same sizes, slices of bread. So she made it a point that she doesn't put a loaf somewhere else in the Ziploc bags. She put slices, but the same sizes there, slices of bread, right? The same sizes, slices of bread, or the same sizes of the slices of bread. Okay, right. Next question. Or next point, next contribution on the validity of these results, right? Of this investigation, right? The same quantity, the same quantity, the same quantity, which was exactly 200 here. Okay, so now we have 20, 20, 20, 20. So she made the point that she puts the same quantity, we'll say 20. The same quantity, 20 their milliliters of treatment. So she made it a point that the treatment itself was not variant. So the treatment itself was consistent. So it was exactly that one there. The treatment itself was that one there. So it was that of treatment. Same quantity, 20 milliliters of treatment across the board, 20, 20, 20, 20 up there. Okay, so instead of 5, how did Amahle make sure that the results of the investigation were valid? She used spray bottle to apply the treatment evenly. Secondly, she decided to place bread in Ziploc bags. Thirdly, all slices they're placed in cupboard. All slices placed in cupboard. No slices were placed somewhere else. Moreover, all left for 1 week, the same time. Right, and next, same sizes, slices of bread. Right, next, the same quantity, which was 20 milliliters of treatment across the board for all the slices there. Okay, next point. Right, so the next point is about the diagrams below show animals that belong to different actually what you call phyla. Right. So now we have these that belong to different phyla, or you can say phyla. Right. So in which case, therefore, You can see, therefore, there is an organism, organism X. There's also an organism, organism Y. Okay, so you can see those organisms, but these diagrams show animals that belong to different phyla, or actually phyla. Okay, so in 2.4.1, name the kingdom to which both organisms belong. What is the kingdom to which organism X and organism Y belong? Because we agree that they belong to different phyla, but now they belong to, name the kingdom to which both organisms belong. They belong to a kingdom. We're here to discuss the different kingdoms, but to what kingdom do these different phyla belong? Right, so we look at the answer to 2.4.1. Right, there's another kingdom we call the Animalia, like an animal, like an animal. Right, so we have the Animalia kingdom. So because these are animals, they belong to basically the Animalia kingdom. But also we understand that they actually belong to different phyla or phyla there. But obviously they belong to a common kingdom, and that is the Animalia kingdom. We're yet to discuss these most certainly in detail, different types of kingdoms to which the organisms X and Y belong, and many other organisms, not just limited to those. Next question. The diagrams below show animals that belong to different phyla, organism X, organism Y. Name the phyla to which organism X belong. Right, so now this organism X, where does it belong? It belongs because they belong to different phyla, right, or phyla, but now to what phyla does this one belong? Organism X. Right, so you can really see that it appears to have 2, 4, 6 there, 2, 4, 6, right, there, 7. So it appears to be having some finger-like, and obviously this is these are popular organisms, all right, right, but you can see that it appears to be having like fingers of the human hand, but obviously it's not the human hand. Right, and then you have 2, 4, 5 finger-like structures there. Okay, appear to be fingers of the human hand, but obviously these themselves are independent animals that have nothing to do with humans quite as such. But if you look at 2.4.2, name the phyla to which organism X belongs, right? This kind of an organism, that is the finger-like structures, 2, 4, 5, 2, 4, 6, 7, there, and obviously it belongs to certain phyla, right? And we call that the, right, we call it the, right, they right, we actually spell the name like this. So it's called the Cnidaria, Cnidaria, right? So the Cnidaria is the pillar to which organism X belong. The Cnidaria, it's the filler to which organism X belong. But we're here to look at, we're here to discuss different filler. Your teacher might have not done this component there, but yeah, the aim of this discussion is to create familiarity with what is discussable. And this organism X, and there are many other organisms we shall look at, actually belongs to the filler called the Cyanadaria there. Okay, next question. Right, what type of symmetry is shown by organism Y? Okay, we understand that in organism Y, there is symmetry. There is symmetry. Right. But what kind of symmetry is observed? Well, the symmetry that we're talking about here is if you look at one end relative to the other end, one part relative to the other part of the organism, there is some symmetry. It appears as if there are great similarities between parts and sides of this organism. Why? What do we call the symmetry that exists in organisms? Because these are animals. What do we call the symmetry that exists in animals? Right. So we have a special scientific name for the symmetry that is observed in animals. If an animal has some symmetry that is observed, one part is similar to another part of the animal. That kind of symmetry in the animal language or life sciences, we call it the bilateral symmetry because you have two similar components. It's called the bilateral symmetry. Right, so the similarity of one part to another part is called the bilateral symmetry. It's called the bilateral symmetry. So what kind of symmetry is observable here? It's called the bilateral symmetry. If you have the symmetry of an organism, it's called the bilateral symmetry because they are one part is actually has some similarity with another part of the organism. Okay, next point. Okay, you need to provide labels for tissue layers. Okay, these are the same organisms. Provide labels for tissue layers A and B. So now for organism X, we need to provide labels for A and you need to provide labels for B. Right, so we're here to do these structures in detail, but if you look at the actual answer to 2.4.4 part A, what is this here? So the A part actually is called right, here is the A part in organism X. We shall discuss more labels of these structures, but obviously it's actually called the ecto. It's called the ectoderm. Right, this part of the organism X is called the ectoderm. Now there is also now part B, and now we also have the tissue layers. Tissue layers part B. What do we call this part? There, this is that part. What do you call the part B? Right, this one is called the ectoderm, and part B because it's sort of inside. Because it's sort of inside. How do we say inside in life sciences? We call it the endo. We call it the endoderm. Right, so because it's sort of in the interior of the structure, in the interior of the organism, is called the endoderm, but this one A is called the ectoderm. Next question. Okay, we're still looking at organisms X and Y. Is asked in life sciences, and we're trying to familiarize ourselves with how questions are asked and how we should respond to them. If you look at 2.4.5, what did we say here? 2.4.5, what do we say here? 2.4.5, what do we say here? Describe the role that organism Y plays in maintaining healthy soil for plants to grow in. These organisms here plays a role in maintaining healthy soil because it makes the soil healthy. This lives in the soil. It lives underground. Okay. It lives in the soil, it burrows the soil, and it makes the soil healthy for the plants. Okay, for plants to grow in. But describe the role. This one. What role does this play to make the plants to grow well and to make the soil healthy? How does this make the soil healthy? So we need to explain there, okay? And we can be able to easily explain that one. And here is the explanation. So this one here is called an earthworm. this organism. Um, because we are interested in discussing it, I'll just mention that it's called an earthworm. We have to look at different kinds of earthworms, but I would mention that first and foremost, what do earthworms do? So the earthworms, right? So we can see that here the earthworms, right? We can see therefore that the earthworms, right? We can see that the earthworms. We had to look at different types of those. But what do they do, these earthworms? The worms that live in the earth, what do they do? The earthworms tunnel. They tunnel through the soil. They tunnel through the soil. The earthworms do what? Tunnel through the soil. Okay, so they just burrow and create some tunnels into the soil and through the soil. Okay, but what more can you say about the earthworms? Right, which aerates, which aerates the soil. So now, as they burrow and as they tunnel the soil, what does this? What happens? Which this therefore aerates the soil, right? You want to say that? If you don't want to use the word aerate because maybe you want to use an alternative term, we can use an alternative term. What is the alternative term for aerate? Right. So it actually allows, by creating these tunnels into the soil, it allows water to infiltrate. It allows water to infiltrate. It allows water to infiltrate. Right, so we are good. Because these earthworms, they create tunnels into the soil, and now water is able to actually therefore infiltrate the soil, and therefore the plants can be able to have water because the water can therefore reach the roots of the plants by being able to infiltrate the soil. Okay, next point. What can you say about this organism here, which is a special type of the earthworm? They eat. Yes, they do. Right. So they eat decomposed. Right. So these earthworms eat decomposed, dead, dead organic material. Right. So in other words, these ones here, what do they eat? They don't eat um, um, food that is fresh. They eat decomposed, dead. Organic material. Okay, the things that have been thrown outside there in the dumping area, then that is what these earthworms are eating. They enjoy the things that have been thrown outside there to decompose. Okay, furthermore, the we continue to say, but as I described the role for Marx there, okay, so you would say basically, we're just writing a little bit more. Right, obviously we note that the feces of earthworms, because the earthworms themselves are able to, or they have feces, they excrete feces, right? So the feces of earthworms are rich, right? The feces of earthworms are rich. Look at this. This is very important for the soil. Now, if you put a lot of earthworms in your garden, then your trees are going to be green and your vegetables are going to actually grow and become healthy because the feces of earthworms are rich, right? They're rich in nutrients, right? They're rich in nutrients for plants. They're rich in nutrients for plants and enrich the soil. The feces of earthworms are rich in nutrients for plants and enrich the soil. The feces of earthworms are rich in nutrients for plants and enrich the soil. So these are the most important, that these earthworms now, they're able to make the soil healthy for plants to grow in, and the plants can be excited there. Okay, next question. Write a comparison of how the plants of two organisms above are suited to their respective mode of movement. You need to write a comparison for 8 marks, but it's 4 times 2. Right, it's 4 times 2. It's 4 times 2. Right. Okay, you need to write a comparison of how the plans of the two organisms above are suited for their respective mode of movement. In the way they move. In the way they move. Let's write a comparison of how the plans of the two organisms above are suited for their respective mode of movement. How do the earthworms move? They move as if they're rolling, they are stretching, and so on. And now organism X as well, you really can see that it spreads that way, but they're able to move. We shall label these carefully. But first, things first. How do these compare? Let's compare them. Let's start with organism X. Right. So we actually spoke about organism X, but we actually first mentioned that organism X belonged to the Cnidaria there, which is a phyla, because they belong to different phyla. But now we're going to start, therefore, from organism X and compare the movements with organism Y. So we shall start with 2.4.6, the Cnidaria. The Cnidaria. How are these? Yes. Let's start with organism X, this Cnidaria. Right. These kinds of organisms, how are they able to have the plans of the two organisms above suited for their respective mode of movement? Let's see that. So we say that it's Cnidaria. They are sedentary. Sedentary. Or these animals are sessile animals. Sessile animals. Therefore, radially symmetry. Radially symmetry allows them to obtain food and ward off danger coming from any directions. Right, so they are sedentary, they are sessile animals, therefore radial symmetry allows them to obtain food and ward off danger coming from any directions because of the symmetry they have. Right, next point. So it's It's 4 times 2. Right. So it's about 2 of each. So, but we're gonna give 3 of each of these. We're gonna give 3 of each. Doesn't matter. Right. These ones, the organism X, what do they have? They have, way to discuss these organisms in detail, but organism X, they have nerves located over the entire body. Right. They have nerves located over the entire body. Right. Entire body surface. Entire body surface. There is no, right, there is no, right, civilization. There is no civilization. So what we are noting is therefore they have nerves um, located over the entire body surface. There is no civilization. So in other words, because of the nerves, they are able to detect and to feel the environment and to be able to detect if they are in danger, if they are being invaded, or they're being attacked. For instance, we then say, right, so they have nerves all over the entire body surface, right? Or there's no civilization, right? So in other words, they can sense the environment. It's not that they're just a dead block moving, right? So moreover, this allows them, this allows the organisms X to sense. They're not just a dead block moving, they can sense equally all around, all around. They can sense equally all around. Next point. The jelly. Okay. So here we're saying they have nerves and they can sense. We here in the first point, we're saying that because of their symmetry, they can be able to obtain food. The second point, they sense these organisms. In the third point, we describe the jelly-like substance. So there's something we call the jelly, right? The jelly-like, right? The jelly-like meso, right? There's something called mesoglia, right? So the jelly-like mesoglia has a network, of nerves, that enables, okay? So we're describing the behavior of these, each of these organisms. We're describing the behavior. Just a sec. So, right. We're here to discuss this in detail and to look at their full descriptions and labels. But the jelly-like mesoglia has a network of nerves that enables enables coordinated movement. Coordinated movement. The jelly-like mesoglea has a network of nerves that enables coordinated movement for, okay, because you can see that it's like a jelly-like structure. If you look at its entire body, right, it's like jelly that has been spread, right? So, right, that enables coordinated movement. Right, so we have that there. Okay, now the next thing would be the organism Y is associated with what you call the annelids. It's associated with what you call the annelids. Okay, so I'm going to erase this because you're going to see this anyway. It's going to be there on the recording. Right. So, but now this is associated with what you call annelids. Right. So, in view of the annelids of the organism we just have looked at, of the worm type, we continue. Of the worm type. Right. So we have 3.4.6. There are things we call the annelids associated with these, because we said that this one associated with the Cnidaria, and this one's associated with what we call the annelids there, okay? And obviously we're speaking about the Tuphilia, the Cnidaria, and the annelids. There for the annelids, for the worm-like, the Cnidaria for the jelly-like structure. Right, so let's look at the annelids for the worm-like organism, which is the earthworm. Right, we continue. What distinguishes them for movement? They have very active, this one's here, they're very active, right, or rather they are very active. That's what I say, they are very active. They are very active and move into new environments. Into new environments with new dangers frequently, frequently. Therefore, they show cephalization, cephalization. They show cephalization. Yes, the other one, organism X, Y also demonstrates cephalization or need sense organs. So this one, organism Y, shows they show cephalization or need sense organs accumulated in the area that enters accumulated in the area that enters right in the accumulating the area that enters the new environment first. Environment first. Therefore, they show cephalization or need sense organs accumulated in the area that enters the new environment first. Okay, because now they keep moving, they enter environments with dangers because they are there in the uh, burrowing into the soil, tunneling in the soil, and sometimes they're exposed to dangers frequently. These organisms, as they move on the surface of the soil and burrowing or tunneling, therefore they show civilization of need sense organs accumulated in the area that enters the new environment first. So they tend to um, advance that part of their body that is more that detects more danger, that has um, accumulated in the area. So now the advanced part of the pod that is more senses, that is more that sort of more detects um, the the surroundings, and that makes them feel either safe or in danger. That's why here we're therefore saying, therefore they show civilization needs sense organs accumulated in the area that enters the sense organs accumulated in the area that enters the new environment first. Next, please. Free living species. Free living species move actively. Free living species move actively from place to place. Since free living species move actively from place to place, they need muscles. They need muscles like us humans. We have muscles. Muscles are just the flesh, okay? Are just the part of the body that is not bone material. Those are muscles. So since the free living species move actively from place to place, they need muscles. Like because in other words, these have muscles there, okay? Because they move from place to place, they need muscles. Right? They've developed they actually need muscles because they need muscles they have developed. They have developed they have developed something we call the mesoderm. Mesoderm. Okay, we're going to describe that from which muscle originate or they are triploblastic. They are triploblastic. Means free living species move actively from place to place. Like we humans, we keep moving. We are living species, and these organisms are also living species. They keep moving from place to place. They need muscles. They have developed a mesoderm from which muscle originate. Right, they are triploblastic. We say sometimes, or if you don't to say the muscle originate, you say they are triploblastic. Okay, this triploblastic is actually one compound word. It has to do with the muscle structure, the muscles that the animals sort of develop because they move from place to place, so they exercise. They're triploblastic because also we humans, if you move, you develop your muscles, you build your muscles by moving. Obviously, you understand that muscles are not only built by moving, but now they are strengthened by moving. Okay. So, and obviously, we therefore understand that. Right. Moreover, there is one more point for the organism Y. For muscle, right? For muscles to work effectively, the body, the body wall of these organisms needs to work independently, independently, independently from what we call the gut walls. Right. So, in other words, for muscles to work effectively, the body wall of these organisms needs to work independently from gut walls. Right. So, we said the body wall from gut walls. So, in other words, we understand, therefore, that these animals have also a gut, like the other living organisms. Right. But we're looking at the worms, they have a gut as well. But now we understand that for muscles to work effectively, the body wall, the body, in other words, the outer body, the outer covering, which is the wall of these organisms, needs to work from gut walls. The development, the development of a column, the development of a column separated, right, separated the body, the body wall from the gut wall. Right, from the gut wall. Okay. Right, so we continue. We continue. Okay, we continue. Right, we continue. Right, so I need to remove the tick here. Need to remove this tick here. Okay, there's a lot we're going to discuss on these organisms that are actually a part of the soil. Okay, so we continue. Okay. All right, let's continue. I want to just to finish this off, which is the one more point about the annelids. The annelids is just another phyla or phyla in which the organisms Y belong, which are actually of the worm type. Right, so right, separated the body wall from the gut wall, from the gut wall. Right, we effectively, therefore, saying for muscles to work effectively, the body wall of these organisms need to work, right, from the need to work independently or separately, like obviously or indicated there, right. I was actually obviously saying here, we need to make sure that this point is very clear. For muscles to work effectively, the body wall, right, of these organisms, right, of these organisms, right, needs to work effectively, right, need to work effectively, right, need to work effectively, need to work effectively from gut walls, right, the development of a what you call a column separated the body wall from the gut wall. So we obviously understand that all right, all right, right. Okay, we continue. Right. Um, we can support the okay. I was then saying, so you note the point that the development of a column separated the body wall from the gut wall. So obviously you have the body wall, and then we also have the gut wall. Okay, we have the gut wall there. Okay, so we continue. We continue. So in other words, we understand that we have the body wall and we have the gut wall, and now the development of a column, right, separated the body wall from the gut wall. So obviously we are just describing the movements of organism Y versus organism X. Take note of this. We're yet to look at these in great detail. So, right, I'm sure that you shall be able to understand the different phyla or the different phyla of different organisms there that live in our environment. Not only that, we need to understand the organisms that live in our environment that burrow the soil or that tunnel the soil and that tilt the soil and make this soil very healthy for us. Right. So, but these here, or most importantly, um, right. So we are looking at, right. Okay. Right. So we continue. Okay. So we look at this question. We're going to tackle this question. Okay, so this is the exam structure of life sciences, please. Um, okay. Well, okay, look at this question as you're thinking. We're gonna tackle it now because it's a very important question. But it's about, okay. So we discussed different animals that burrow the soil, live in the soil, and make the soil healthy, and we described their movements, right? Right, right. So we continue. All right. If you look at question 3, for instance, the table below shows the average atmospheric carbon dioxide level over 60 years. Okay. Okay, we continue. Okay, I'm sure that this you have already seen, but we'll discuss this now. We're going to answer these kinds of exam questions together, and you shall just get familiar with how we answer questions based per section, because these questions are questions per section. So you need to just make sure that you are familiar with these. Okay, so the table below shows the average atmospheric carbon dioxide level over 60 years. Okay, so we learn about the greenhouse effect. The greenhouse effect, or the greenhouse effect, is a very important effect. And so um, this is going to come in the exam, paper 2, greenhouse effect. The earth, the carbon dioxide accumulation in the atmosphere, and so on. Okay, let's read this and look at how you need to answer questions about the greenhouse effect. Okay, it's not that I'm just bringing these questions to you. It is what the subject is about, it's what the exam is going to be based on. So we are preparing here so that, because in English they say if you are forewarned, then you are forearmed. Okay, we are here to discuss a lot of the life sciences in depth, but it's very important that you sort of understand what is happening. But let's look at the table below, shows the average atmospheric carbon dioxide level over 60 years. In 1962, the carbon dioxide concentration parts per million was 318,46 parts per million. In 1967, it was 322,13 parts per million. Okay, if you analyze these figures in life sciences, you are able to see the actual increase. So there's an increase from 318 to 322. Okay, and then now you have as well 1972. In 1972, it increased from 322,13 to 327,52. Okay, we're looking at what is happening here. Okay, right. Okay, in 1977, it increased to 333,88. Okay, right. Then in 1982, right. So in 1982, what happened? 1982, you can see the increase again. What is it? 341,09. In 1987, from 341, there was 348,99. These are carbon dioxide concentrations, parts per million, in the atmosphere. Well, speaking about atmospheric carbon dioxide here, okay? All right. So in 1997, it even increased. So it increased quite consistently. Why is it necessary? Okay, let's look at the diagram one. The greenhouse effect in 1962, right? And then now you are also looking at diagram two, the enhanced greenhouse effect 2017, right? So what is the difference between the two diagrams? You can see that in 2017, it is a bit bigger. But in diagram one, it's a bit thinner. The sort of the carbon dioxide concentration in view of the atmospheric carbon dioxide level over 6 years. It looks a bit thinner here, but it's much thicker here. So in 2017, the concentration parts per million was higher, 406.55, and here it was 318.46. Okay, observe the difference. Okay, just observe the difference over there. Next question. We're asking the question here, what is happening about this? We can see that here in 2017, the concentration parts per million has increased to 406.55. In 1962, it was only 318.46 parts per million. Why is it necessary for the natural greenhouse effect to be maintained? Why? Why is it necessary for the natural greenhouse effect to maintain? So in the exam, you're gonna have this discussion about the greenhouse effect. How must it be maintained? This how? Question 3. Question 3. We're asking the question, why is it necessary for the natural greenhouse effect to be maintained? How is it necessary? Okay, this is part of what is examinable. Okay, we're looking at 3.1.1. The greenhouse effect, what does it do? It warms up. It warms up the atmosphere. It warms up the atmosphere. So you must know about the greenhouse effect for paper 2 life sciences exam. I'm yet to discuss that a little bit in detail, but take note of what must be known for the exam. The greenhouse effect, what is the purpose of the greenhouse effect? There, and we answer the question right now. We're saying it warms up the atmosphere. It warms up the atmosphere to sustain life. It warms up the atmosphere to sustain life. Okay? So, in other words, the atmosphere must be warm for life to be sustainable. Because if the atmosphere is very cold, then life is not going to be sustainable on Earth. Okay? So, why is it necessary for the natural greenhouse effect to be maintained? The reason for it is because the greenhouse effect warms up the atmosphere to sustain life. Next question. Obviously, you can see that you have lots of emissions here of the carbon dioxide gas level, and you can really see that there are lots of emissions, and the concentrations of the carbon dioxide in the atmosphere continue to increase in parts per million. Okay, so we are good. We are good. In 3.1.2, name 2 human activities that cause an enhanced greenhouse effect. Name 2 human activities that cause an enhanced greenhouse effect. Okay, there are 2 human activities that cause an enhanced greenhouse effect. What are those in 3.1.2? What are they? What are they? Why is it, what do the humans do to contribute that cause enhanced greenhouse effects? Because the people chop down the trees in the environment. So this is what we call deforestation. Right, deforestation. So deforestation is one big problem. So deforestation is what enhances greenhouse effect, or it elevates it. It increases greenhouse effect, the removal of trees up there. But not only the removal of trees, but also we speak about the burning of fossil fuels. Okay? The burning of the fossil fuels. What are the fossil fuels? So the people are burning coal. Coal is a fossil fuel. People are burning diesel in the cars, the trains, the petrol in the cars, the etc. So the petrol and the diesel, people continue to burn those, and those are fossil fuels. And those fossil fuels, what do? They enhance the greenhouse effect. Okay, so now that is one thing that we're observing. So now we're able to see the atmospheric carbon dioxide level over 60 years. Next point. There is a large scale cattle farming, larger scale cattle farming. So some people grow a lot of the cattle in the villages and also on farms. And so now what happens is the large scale cattle farming, or what you call the rice paddies. Right. So in other words, what people do is they grow a lot of large scale cattle farming. Too many cattle, they finish all the grass. They finish all the grass. They actually consume much vegetation. And that also, does it do? It enhances the greenhouse effect. Okay. What is the next thing? So now, these are the points you need to note. How do the people increase deforestation? How do they do it? Because the people, they're chopping down the trees in the environment. After chopping down the trees, they burn the fossil fuels, they burn the coal, they the people grow a lot of the cattle, and the cattle, what do? They keep breaking down. They eat everything. They eat much of the vegetation, and there's no vegetation left. And the earth becomes bare. It becomes naked. Okay, so that enhances also the greenhouse effect there. Okay, so that is the human activities that they needed two, but we gave three. We know, I note that. I know that we gave three of them: deforestation and the chopping down of trees or removal of trees, the burning of fossil fuels, and also now because and also the large scale cattle farming there. Okay, those are the human activities that contribute to greenhouse effect. Next question. Okay, we've read about the concentration of carbon dioxide and also the increase in the concentration of carbon dioxide parts per million in the atmosphere. Now you can see the thickening of the atmosphere, and here it's becoming thinner. It's becoming thinner. Diagram 1 shows the natural greenhouse effect in 1962. Right? 1962. While diagram 2, this was 1962. Here's the diagram. 1962 for 1962, the diagram is this one. Diagram 2 shows the enhanced greenhouse effect in 2017, just a few years ago. Right? In 2017. Using the data in the table, explain the change shown in the diagrams. Using this data in the table, how was this diagrams different? This diagram, obviously, there's sort of a change. That's what the examiner called it. So using the data in the table, explain the change shown in the diagrams. So we're going to look at 3.1.3, the change observed in the diagrams, right? So we observe that the carbon dioxide, right? If you look at the two diagrams, the carbon dioxide, right? The carbon dioxide concentration. Okay, some of these things maybe I need to discuss them in class. The carbon dioxide concentration, in the atmosphere? The carbon dioxide concentration in the atmosphere increased? Increased? Right. So we can see, therefore, that the carbon dioxide concentration in the atmosphere increased here. Okay. Here it was less, but here it is more. The layer is thick, right? Or is thicker, right? So now next, this caused more heat, radiation, more heat radiation to be absorbed. To be absorbed or trapped by the atmosphere. All right. Trapped by the atmosphere. The carbon dioxide concentration in the atmosphere increased this, or rather, the carbon dioxide concentration in the atmosphere increased. Okay, we can see that this one is thicker than that one. So we can most certainly conclude that the carbon dioxide concentration increased in 2017 relative to 1962. This caused more heat or radiation to be absorbed or trapped by the atmosphere. So if the carbon dioxide concentration increases, it means more heat or radiation is absorbed or trapped in the atmosphere or by the atmosphere. So we note that if the heat is trapped in the atmosphere, if there is a higher concentration of carbon dioxide. Next. Okay, this caused more heat. Right, radiation to be trapped or absorbed by the atmosphere. Right, so, and less heat or radiation to be reflected. Right, and less heat or radiation to be reflected. So in other words, the heat was mostly absorbed in the atmosphere. That's one thing that must be noted. It was absorbed in the atmosphere. Three point 1.3. Next question. Okay. The information in the two diagrams is still the same, but they are asking us now at the grade 11 question on the greenhouse effect, the emissions of carbon dioxide by Eskom, because Eskom in South Africa produces mostly a form of electricity we call thermal electricity. Thermal electricity is produced by burning coal, and that is what Eskom is using. So in 3.1.4, you should explain how the increased climate change affects food security. So now you actually continue and explain how the increased climate change affects food security. So if we are saying there's an increase in climate change, how does that affect food security on Earth for us? Does it mean we are food secure or we are food insecure? Okay, so those are the kinds of things that we discuss now. So now the truth is, if there is an increase in the carbon dioxide concentration or there's increased climate change, food security is decreased. Right. So in other words, if we have too much carbon dioxide in the atmosphere, if it's a lot, then food security is decreased. So it means that we can find ourselves with less food for us to eat. So, but also if there is increased climate change, we say that there are specific changes in rainfall pattern. Rainfall pattern. The increased food security is decreased, the changes in rainfall pattern. So in other words, the increase in climate change, what does it do? It creates changes, or there will then be changes in rainfall pattern. Cause what? So now there will be changes in rainfall pattern because of the climate change, right? So now you might find that therefore the rain does not fall at the right time. At the time that you expect rain, there's no rain. So it's like the seasons are being tempered with because of the increased climate change, and that is caused by the atmospheric carbon dioxide level that continues to increase unabated. So we then say there is also desertification. Desertification. Desertification now, what is desertification? So now we understand, therefore, that if the rainfall pattern changes, then we are likely to find ourselves in deserts. The areas in which we live will have less rain, and therefore we have less water, and so on. Right. Also, there is an increase flooding. We saw a lot of increased flooding in the Cape, in Cape Town, over the past couple of days. And some people were swept by the water in the Cape. Okay. Right. Not only in the Cape, but also we saw the same pattern in KZN, okay, in KwaZulu Natal. And now in the two provinces, we saw that we are seeing that these patterns are patterns of climate change. These are signs of climate change that affect the Cape, and also they affect Durban, because those are amongst areas, the coastal areas of South Africa. Right. Moreover, if there's increased flooding, so in other words, the floods sweep people away and destroy power lines, and some people find themselves without electricity in Cape Town and also in KwaZulu Natal, KZN. And also, the carbon dioxide concentration that increases unabated causes an increase in climate change, but also the things we call the wildfires. The wildfires. So the wildfires refer to the fires in the bush, right? So now the bush is burned because of the um, dryness of the environment that is caused by the increased climate change, which is caused by increase in carbon dioxide levels over the years. Next question, which now changes in rainfall pattern cause, which increases, soil erosion, which increases soil erosion, resulting in, right, which increases soil erosion, resulting in, okay, resulting in fewer crops to be planted. Resulting in fewer crops to be planted. Resulting in lower crop yields. Lower crop yields. Resulting in less food for livestock. So we are speaking about the changes in the rainfall, what? In the rainfall pattern. And now these changes in the rainfall pattern comes with fewer crops to be planted, comes with lower crop yields. So the crops do not grow very well, right? But moreover, we observe that there are less food for livestock, because if there are changes in the rainfall pattern, it means that even the grass doesn't grow very much and the trees do not grow very much, and therefore there is less food for the animals, for livestock. The animals that are grown for food, the cattle, the goats, the sheep, and so on, right? They do not have enough food also to graze as pastures. Okay, next, we also continue to make certain observations about the higher environmental temperature. So there is a higher environmental, higher environmental temperature. Right, negatively affects livestock. Right, so the higher environmental temperature negatively affects um, livestock, negatively affects livestock. Or crops. Higher environmental temperature negatively affects livestock or crops. Next, there are certain factors. So these factors further decrease. These factors further decrease food availability. 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 Food becomes more expensive. If the rain is less and the rain, or rather the changes in rainfall pattern, the food becomes expensive. Like the people, if you go to the shop now, you see the eggs are expensive. You see the cooking oil is expensive. Right, you see that things are becoming very, very much expensive. So food becomes more and more expensive. Why is the food becoming more and more expensive? right? Because now there are changes in rainfall patterns and there's less food that is growing. The crops now, as we mentioned here, lower crop yields. So there are lower crop yields and therefore the food is less. Now they're growing much, but we have lower yields and therefore the farmers are harvesting less of what they expect to harvest. That's a consequence. What is happening is therefore that there are lower crop yields, and therefore, in the end, we have that the food is less, and the food is becoming food becomes more expensive, like the cooking oil we see in the shops, the eggs that have skyrocketed in prices, and so on and so forth. These are just factors of that are actually signs of increased climate change. What is causing the increased climate change is actually the average atmospheric carbon dioxide level in the atmosphere. We see that it continues to increase in 2017 relative to 1962, and it continues to increase every day. And we can see, therefore, that we must be very careful of our actions. We must avoid actually causing a lot of deforestation. They're causing a lot of wildfires, burning a lot of fossil fuels that cause the carbon dioxide in the atmosphere to increase and therefore to trap much heat up there. Okay, so those are the kinds of things we discuss. But next question. So what did we discuss here? We looked at how we had to explain how the increased climate change affects food security. So in other words, the increase in climate change affects food security and how? How is it that when Eskom builds a lot of power stations, then we shall have less food in South Africa? Not only in South Africa, but in the world, because this atmosphere and the carbon dioxide that goes into the atmosphere does not only remain in South Africa, because the power stations by Eskom, they release a lot of the carbon dioxide into the atmosphere, and the atmosphere of other countries also gets affected, and the destruction of what we call the ozone layer in the atmosphere. So those are the kinds of things that burning the cars, now we need to change from the model of transport, the mode of transport that uses petrol and diesel and oil. We need to be changing to electric cars, because the electric cars will not be emitting the fumes at the back, like in the through the exhaust pipes. Now, if we use a lot of the electric cars, then we shall not actually release a lot of the. So this is not going to thicken the atmospheric carbon dioxide level. So these are the kinds of things that we just need to focus on. But let's look at the next question, please. Okay, there are things that are very important. So the population is very important, and we shall discuss the idea of the population over a period of many years. Right. For example, rabbits were introduced to an Eastern Cape farm in 2006. In the Eastern Cape, rabbits were introduced to an Eastern Cape farm in 2006. Since then, the rabbit population has increased rapidly. Right. The graph below shows how they have increased. So somebody decided to farm rabbits. And now these rabbits are like cats, but their ears are long and etc. So and normally they can run really, really, very, very fast. But now, right, so the rabbits were introduced to an Eastern Cape farm in 2006. Since then, the rabbit population has increased rapidly. Okay, the population increases. In 2006, they increased a little bit. After 2008, they went up. In 2010, they also went further up in 2012. And then you can see that there after 2016, they are furthermore increased. But now you can see that now they appear to be fluctuating. So in other words, after 2016, there is a sudden fluctuation, a sudden decrease followed by an increase, a decrease followed by an increase. It's a fluctuation. So provide labels for phases. So when you're studying population dynamics at grade 11, it's very important to understand how the population here must be studied. So in 3.2.1, provide labels for phases B. What is this phase here? And also, what is this phase here? Right, so we're studying population, Right, so we are studying population. So now, studying population allows us to make certain observations about the population. Right, certain observations. I'm going to stop at 6. Right, about the population. What do you observe about the population? In part B, okay, right. In part B, we can see there is a geometric. So in other words, we're looking at the answer to 3.2.1 part A. So in part B, we are seeing a geometric. A geometric or logarithmic or accelerating growth. In part B, you are seeing the geometric, or it's called the logarithmic, this one here, or you call it also called the accelerating growth. That is when you study population. Okay, there's this part here. What do you call the part C that is about to level up a little bit? That one in 3.3.1, part B, the part obviously the C. This one is called the logistic. We must know the different components of the population curves. Right, so you have we call it the decreasing growth rather. Okay, the correct term for that is actually the decreasing growth. Right, so in other words, that part, because you can see that is beginning to decrease, the right word for that is called the decreasing growth. Right, so now part C, therefore, is called the decreasing growth part of the population curve. Decreasing growth. Okay, 3.2.2. Decreasing growth here. Here we have the geometric or the logarithmic, or you can call it the accelerating growth. This one is called the decreasing growth. Let's look at the next one. We're looking at 3.2.2. Right, so we have the same thing. Name the type of growth form showed in the above graph. Name the type of growth form showed in the above graph. What is the growth form showed in the above uh, graph? Right, so we can see that there is suddenly a growth and then a decrease. What is called this one that is the shape that is like this? Right, it's called the logistic. It's called the logistic growth form. Goodness me. It's called the logistic growth form. It's increasing and then it's starting to level. So it's called the logistic growth form. 3.2.3. Give the letter of the phase where birth rate equals death rate. When you study population, we have those that are born, there's birth, and then there are those that are dying, there's death. So in 3.2.3, the birth rate equals death rate in which part of the graph? Okay, so it's where it begins to level off at this point here. So if you look at 3.2.3, right, in part A, or this one A, you have part D of the graph, is where the birth rate equals the death rate here, right? So, but if you look at part B here, natality exceeds mortality. Natality is the birth. in mortality. So natality has to do with those who are born, and mortality, those who are dying. So now, in other words, obviously we're speaking about the population of the rabbits, etc. So now some of the rabbits are dying, some of the rabbits are being born, right? And there are reasons why some die. Okay, we're not looking at that, but look at natality exceeds mortality. So natality exceeds mortality means more are born, right? Give the letter where that is happening. More are born than those rabbits that are dying. So obviously we can see that it is part B, because in part B, the population size is increasing rapidly. It means more are born and fewer they are dying. Okay, right. So we continue to look at further questions on this front, and as we analyze this much in detail. Right, let's look at the next question. Okay, we're still looking at this. Explain why the rabbit population size did not increase permanently after point E. After point E, why did it not increase and suddenly it was fluctuating? You need to explain that those rabbit population size did not increase. Why? Why suddenly there was stagnation in the rabbit population size? It was fluctuating. Why the rabbit population was fluctuating there? It's because, why does the population fluctuate in life sciences? The reason is that the rabbit population had reached carrying capacity. It reached carrying capacity. Okay, the rabbit population had reached what? Carrying capacity. The rabbit population had reached carrying capacity. So in other words, now when it reaches carrying capacity, you can see that there is some fluctuation there. So carrying capacity is the maximum species that can be catered for in an environment. Right. So, but we're looking here at the environmental. Right. The environmental resistance. The environmental resistance occurs, or the density dependent factors. Factors prevent population from increasing. Frog food, frog space, or water becomes limited. Water becomes limited. These here, these prevent population from increasing further. So we have a rabbit population had reached carrying capacity. We're saying, why is it that there's stagnation here and there's no more growth? Because it was growing fast, and suddenly it is beginning to zigzag. Why is it beginning to zigzag? Right, because the rabbit population had reached carrying capacity, okay, so it can't grow further above that. The environmental resistance occurs, or density-dependent factors prevent population from increasing. Food, space, water becomes limited, okay, because now there's less water, there are too many of these rabbits, and now the water is less, and therefore they can't increase beyond that. These prevent population from increasing. Right. So in other words, these things here prevent population from increasing. So you can use this, or you can use that one for the plural form, prevent the population from increasing. Right. Let's look at the next question. Right. About population. Okay, the rabbits are there already, and you can see the population is what is beginning to increase very tremendously. Right, it was decided to determine the size, right, of the rabbit population from a farm or on a farm in 2020. 40 rabbits were collected at random. Each one was marked with a tag on its ear and then returned to the farm. After 1 week, the second random selection of rabbits was collected. And the diagram below shows the rabbits that were caught during the second selection. Right, so this one shows the rabbits that were caught during the second selection. Name the technique that was used to determine the population of rabbits. Okay, they want to determine the population of the rabbits, but what is the technique? Now they just catch these rabbits and then each one is marked with a tag on its ear. What kind of a technique is this one? Right, this one is called the mark. It's mark recapture. It's mark recapture. Because why is it recapture? Because they mark them, they release them, and then they recapture them. Because now, after 1 week, a second random selection of rabbits was collected. So they marked them and then they released them into the farm and then they recaptured them. Okay, so we continue to look at the next one, 3.2.6. It was, so we have that one there. Right, using the formula below, determine the number of rabbits on the farm in 2020. So we must be able to use this formula. Right, what is this formula? The formula says that the population is equal to the number originally marked times the number in second sample divided by the number marked in second sample. So what is this formula used for? It is used to determine the number of rabbits on the farm in 2020. It's used to find the population. What format do we use to find the population of the rabbits in life sciences? We say population is number originally marked times number in second sample divided by the number marked in second sample. Right, so that is 3.2.6. Let's do the calculation over there. Okay, right, so this one here can be done most certainly with ease. How do we do this calculation? So we'll then say population. Right, we'll then say population is equal to what? This population. So population is equal to, right, the number originally marked. How many rabbits were originally marked? Remember, on a farm, 2020, 40 rabbits were collected at random. So it means that the number that were originally marked were 40. Multiplied by number in second sample, right? So after 1 week, a second random selection of rabbits was collected. Diagram below shows that. Right. Sorry. Right. Each was marked, etc., and retained on the farm, and you have this particular collection. But now, right, you have that there. Right. I want to mention that it was decided to determine the number of the marked population. Right there. 40 rabbits were collected at random. Each one was marked with a tag on its ear and then returned to the farm. 1 week, after 1 week, a second random selection there of rabbits was collected. The diagram below shows the rabbits that were caught during the selection. Right, we need to determine now the technique that was used to determine the population of the rabbits. We have answered that one, all right? Right, so the number marked in second sample, how many were marked in second sample? 1, 2, 3, 4. Right, so you need to just perform the division here. The number that was marked in second sample, only 4 rabbits were marked in the second sample. It's this one, that one, and that one were marked in the second sample. So now the number in the second sample Right. How many were the number in the second simple? Right. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I might repeat 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I'm expecting them to be 25 of them. Right. So number in second simple, I'm expecting them to be 25. All right. So now if you therefore multiply here, okay, you can count 1, 2. Let me check the time. My fear is that your load shedding might just kick in now. What is your time there? All right. So
It's
yes, what is your time?
it's 5:57.
Yeah, it's just about time. Okay. So right. So I wanted us to play around with this formula here, but yeah, I'm fearing time. But now you look at this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did not put 9. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So you have 21, 22, 23, 24. Which one did I miss? I missed something. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 9 twice. 25. Okay. So there are 25 altogether, these rabbits. Right. So, and that is why here, the number in the second sample is 25. And originally marked is 40. So the population is 250 rabbits. Okay, I must thank you for joining us. I'm going to send you the video in the next couple of minutes. Okay. Your load shedding is happening now. Goodbye.
Bye.
Goodbye.